All right, I'm sorry for the disruption. This may have to be two videos eventually. All right, so now let's look at it. So I will name the first one video one, then the second one video two, multiplication of matrices. All right, so now from where we stopped, we have the matrix A to be the same thing as A, B, C, D, E, F, G, H, I, and J, K, L. Then we have the second matrix as B, which is a um, M, N, O, P, Q, R, S, T, U. So like we said earlier, this is obviously a 4 by 3, and this is a 3 by 3. So since the columns of this one is equal to the row of this, then we are good to go. And we know that the result is going to be a 4 by 3 matrix. A 4 by 3 matrix. That's what we are going to. So let me come here and say A times B is going to be this 4 by 3 matrix, which is going to be, let's call this one x1, x2, x3. It's going to be a 4 by 3, which it will have 3 columns and 4 rows. So y1, y2, y3, z1, z2, z3, then omega 1, omega 2, and then omega 3. So what we need to find now is x1, y1, x3, sorry, x1, x2, x3, y1, y2, y3. If we can fill in these two variables here, then we are good to go. All right, so this is the process. Now you will see the reason why the number of column here must be equal to the number of rows here. So let's say we are looking for x1. All right, so let's say we are looking for x1. So it's going to be like this. X1 is going to be, so x1 here is in the first row, and the first column. All right, so then you come here, you pick the first row and multiply it with the first column. So you see the number of rows here, the number of columns here is 3. 1, 2, 3. And it's now equal to the number of rows here, 1, 2, 3. That's the only way you can do the multiplication and addition. So we call it the linear combination. So it's going to be A M, A times M, plus B N, that is B times N. That is, you take this item to multiply this item, you take this item here to multiply this one, then you take this one to multiply this one, then you just add everything together. That's plus C whole. So whatever the answer is, okay, this is going to be x1. Then you go to x2. X2 is on the first row and the second column. So what's in the first row will still the same thing, and what's the second column? PQR. So x2 is going to be you saying A, which is the first item in the first row, times P plus B, which is the item here, times of course you guess right, Q, plus C times you guess right as here, C times R, C times R. Then you go to the x3, and it's going to give you, okay, x3 is on the first row and the last and the third column. All right, so you go here, the first row, which is A, B, C. Okay, let me make it a little bit fun. So let me write the items on the first row. A, just leave a gap, plus B, just leave a gap, plus C. All right, all right. So then you come to, okay, this section, which is the first, the third column. Then you put the items here, AS plus B L and C U. So that's all. We are done with that. Then let's move on to, if we can continue like that, it means that we are going to do this for 12, and I think we can just pick. Let's pick at random. Let's pick what is going to happen to y3. Let's say y3 now. All right. Let's assume that you have done y1 and y2 exactly the way we have described. So if you are doing y3, y3 is on the second row and the third column. So you come here. Where's my second row here? Oh, this dude here. This is my second row, and my third column is still this guy here. So let's write out everything in the second column. In the second row, I mean, that's D, E, and F. Now let's multiply it by everything we have on the last column, which is a SLU. So SLU, then add. That's fun. That's so much fun. So we have found that. Let's say we're looking for the item omega omega 2. Omega 2 is on the last row and on the second column. So column 4. So it means that we are going to be looking at this column 4. So I write out all the items in column 4, which is going to be J, K, L, and all the items in um, sorry, I mean row 4. I'm sorry, not column 4. Then all the items in column 2. So that's going to be P, Q, and R, then add. Voila, we are done with that. So maybe just for us to have one last fun, let's look at omega 3, which is the last item here, which is fourth row and the third column. So what do you have in the fourth row? That's a J, K, L. What do I have in the last column in B? That's a S, L, U, S, L, U. Then just add. That is all. That's how matrix multiplication is done. So I'm going to save this page so that I can move on to an example, the example that you sent to me in the class the other time. So let's look at this example. Let me pick something that looks like more serious now. Oh, shoot. Okay. Okay. All right. So, so this example says that we have this matrix minus 1, 1, 0, minus 2, 3, minus 2, 2, minus 2, and 1. And we are multiplying it by x, y, and z. And the result is going to give us 5, 17, and 5. Now let's look at this. Does this make sense? This is a 3 by 3 because it has 3 rows and 3 columns. Now this dude here is a vector. It's a vector because it has only one column. All right, but it has 3 rows, either we like it or not. So it has this a 3 by 1. So the item here and the item here are equal, so it means that we can multiply the two, and the result is going to be a 3 by 1, which is what we have here. This is a 3 by 1 matrix. So we are good to go. Now let's look at the multiplication. We are expecting to have a 3 by 1 matrix. So definitely um, we should have something like okay, it's actually already there. It means that when we multiply this when we multiply so when we multiply these rows with this column and add the items, the result must be 5. That's what it's saying. So it means that we have minus 1 times x plus 1 times y plus 0 times z. The answer must give us 5. That's the first situation. Now the second situation, to get 17 here, then it means like what we did earlier, minus 2, um, 3, minus 2 again, just setting the column into it, x, y, z. Then you put addition here. Of course, this negation is already here, so you don't need to put anything. It's now 17. And the last one is going to be 2, minus 2, and then 1, then x, y, z. Okay, put a plus here to complete it, is equal to 5. So what we have there is a system of simultaneous equation. Simultaneous sine equation. Now, things are easier now. You don't have to solve simultaneous equation manually again. Okay, you don't have to solve it manually again. You can just what I often do is that I can just load it into a simultaneous equation calculator, and it would give me my answer. The one I often use um, is Microsoft Math Solver. You can download it on your phone. All you have to do is to write out the equation the way I've written out this. Then you snap it. I mean, you scan it with the solver, and it works. Let me see if I can do it here. Okay, the solver. Is that the solver? I don't think so. It looks like it. Okay, that's not the solver. That's another calculator. Let me look for the solver. Let me look for the math solver. Okay. Yep. Here you are. So this is the math solver. Okay. Let me demonstrate how it works. Perhaps you have an idea of it. You should. But then I don't want to. So you have to be very careful with it. That everything you want to work with is actually inside the box. If there's any other thing, it's going to mess it up. Oh, it's my hand shaky. Okay, okay. Good. So let's wait and see. If it makes any mistake, you can correct it. Oh, didn't detect anything. Sorry. Let me go at it again. Oh, fantastic. So let's confirm that. Okay, it has solved it. You can see it's x equals 32, y equals 37, and z equals 15. It's just like that. Simple as that. So if you want to see how the solutions are done, then you come here and you see it. It uses a substitution method to solve it. Of course, I'm sure you have access to other form of you know, calculators that can solve this problem for you. So that is how that is done. You don't need to go through the stress of using solving it manually. But then the reason why I'm explaining all these things to you is so that when you have some crafty questions, you will be able to know how to reach the point where you can use the calculator, because that's the whole essence of mathematics. Now, so we have been able to solve that. There are, if you load the same question into graphing calculator, you are going to get the same solution. Now, the last thing I will be discussing in this video now. The last thing I will be discussing in this. Okay. Let me write out the answer to this system of equation. So when you solve this problem, you are supposed to get x to be equal to 32, and y to be equal to 37, and your z to be equal to 15. So yeah, you can test it with your other devices, but the easiest one for me is that's Microsoft Math Solver. All right, so I'm going to save this page again. I'll send you the page later, the pages later, the ones I've saved. So now we want to talk about the crafty one, which is the inverse of a matrix. Matrix inverse. All right. So now the idea of matrix inverse is very simple. It's very simple. So you have a matrix here. What's the inverse of a matrix A? That is A raised to power 1. Of course, when you multiply A by A raised to power 1, it should give you 1, which is the normal identity element. Okay? But in matrices, it must give you the high, which is the identity element. So if you have a, let's say you have a 2 by 2 matrix. Let's say A is a 2 by 2 matrix. That is, A is a, and this is just a theory, so you don't really need it. I'm just explaining the theory. So if A is let's say A, B, C, D, all right. Now you need to move to find the inverse. You need to multiply it by the inverse, which is going to be X, Y, Z, say omega now, and it must give you the identity matrix. The identity matrix is a diagonal matrix which has 1 in the diagonal and 0 in other places. So when you multiply this and this, it must give you that. So what you are looking for in essence is the omega. I mean, what you are looking for is this value, that when you multiply it with this value, it must give you the identity matrix. Okay, now that's the theory behind it. Now let's look at the process. So the process is a little bit long, and if it's just for a 2 by 2 matrix, then it's a little bit shorter. But then for this is 0, not 6. All right, but it's a little bit shorter. All right, so I think it's best for me to demonstrate this using a 3 by 3 matrix. Then we'll talk about the steps. The steps are a little bit long, but we can talk about it. All right, so let me clear this page so that I can start the steps. So step one, so inverse of a matrix. So I think the best for me is to write out a matrix first. So let's say our matrix is M, which is what I have here is 1, 2, 3, 0, 1, 4, 5, 6, 0. So and we're asked to find the inverse. So find the inverse. All right, find the inverse of A. So we have to find the inverse of A. Find the inverse of A. It's not difficult, but you have to be very careful with it. And all this, what I'm saying is that, of course, there are calculators that will find it for you. Of course, you just punch the numbers in the calculator and it gives you the result. But then you need to know the theory behind it, so that if they ask you something funny, you may need to do some one or two things on papers before you load the result into a calculator that will calculate whatever for you. And that's the reason why I think we should go through this process. Now, okay, the first step one, step one. You know, we have to turn this matrix into a number first, which is called a determinant. So find the determinant of find the determinant. Determinant m of m. We need to find that first. Okay, and if okay, let me assume that you are not familiar with how to find the determinant of matrices. So let's quickly do it. So let's say this is m equals, like I said, 1, 2, 3, 0, 1, 4, 5, 6, 0. So this is my determinant. Okay, now I'm sorry, that's my matrix. The determinant m, the determinant of m, which is the same thing as det m, will be found as those. So you pick the first item here. So you just use the first row. The first row is like your marker. So you pick the first item on the first row is 1. Then you blind the column which one is. So that gives you a 2 by 2. That gives you a 2 by 2 matrix. So you find the determinant of that 2 by 2 matrix. That's 1, 4, 6, 0. We'll talk about that. Now, so this is a plus, then use a minus, and this is a plus. So here is 2. Okay, so you say minus 2. Of course, this column is already blinded for you automatically. Then you blind this column. All right, of course, you can now release the first column that you have blinded. So you have 0, 4, 5, 0. All right, then the third one will now be a plus 3. Okay, so you open the determinant, then blind this, then release the others. So when you release the other, then it means that you are going to have 0, 0, 1, and I think 5, 6, 5, 6. Okay, let me be sure. Okay, I think I might have made a mistake somewhere. Let me just be sure. Okay, so this is going to give you 1, 4, 6, 0, 0, 4, 5, 1, 0, 1, 5. Okay, okay. Mm, 6. Yeah. So I'm good to go. So this is going to be 1 times. So now the determinant is you multiply the diagonals, starting with this one, like cross multiplication. That's 1 times 0. That's 1 minus 4 times 6. That's 24. Okay, 1 times 0 is 0. Sorry. 1 times 0 is 0. So minus 2 now times 0 times 0. That's 0. 5 times 4 minus, that's 20, plus 3 into 0 times 6, that's 6. 0, sorry, minus 5 times 1, that's 5. So when you resolve this one, it's going to be minus 24 times 1, which is minus 24. 0 minus 20, that's minus 20 times minus 2, that's plus 40. Then minus 0 minus 5, that's minus 5 times, that's minus 15. So this is going to be something like a 40 minus 39, which is equal to 1. So we have, so therefore the determinant of m equals 1. That's very, very important. That's very, very important. If the determinant, if you're asked to find the inverse, let me clear the screen. Okay. If you have to find the determinant of if you have to find the inverse, to find the inverse, to find the inverse of a matrix, the determinant, okay, of a matrix M, the determinant of M must not be equal to 0. So that's the first thing. Immediately you run this determinant. If when we run this determinant, if it gives us 0, then we know that the inverse of that matrix cannot be found. So we won't have to bother. We will just stop at that point and not waste our time any further. We just continue with the next question. So you can see I've actually seen a problem like that in one of the notes you sent earlier to me before, where the determinant cannot be found. I mean, actually, the system of simultaneous equation cannot be found because it is faulty. All right, so we have that now. So now let's look at the second step. So we have found the determinants. Don't let's forget about that. So determinants found to be, so for M, okay, for matrix M, okay, depth of M equals 1. So let's move on. Now let's find the stage 2 or step 2. Okay, I may need to go a little bit slow. Step 2, find the transpose of M. So now if M is what we say it is, which is a 1, 2, 3, a 3 by 3 matrix of okay, 0, 1, 4, 5, 6, 0. All right, then M transpose is going to be like this. Now it's very simple. It's another 3 by 3 matrix. So you take the column here, sorry, the rows here, and it becomes the column here. That's now 1, 2, 3. So you take this one and it becomes 0, 1, 4, and then take the last one and it becomes 5, 6, 0. So you have successfully calculated the transpose over that graph of that matrix. Now the stage 3 is to find the adjugate or the cofactor. So step 3, find the cofactor of M transpose. So we find the cofactor of M transpose. All right. So let me clear the screen again. Save the page I may say. So so we know that M transpose from what we did just now is so 1, 0, 5, 2, 1, 6, and 3, 4, I think 0. Okay, so having this is very simple to find the transpose. It means you know what we did for the column, for the row when we were finding the determinants the other time. We do it for the we did it for the first row, but this time around we do it for every number, every row on this on this transpose. So it's going to be so here for one for this first item, of course you blind the row and the column it belongs to. So you have 1, 6, 4, 0. So so you are going to have say for one now, it's going to be the of 1, 6, 4, 0. When you close that, so it's going to give you 0 times 1 minus 6 times 4 is going to be minus 24. Okay, um, for 0, that is this item here, so it's going to be for 0, you are going to have, of course, clear the row that contains 0 and the column that contains 0. All right, you clear those two. All right, then you are going to be left with 2, 6, 3, 0. So we have 2, 6, 3, 0. If you take the determinant of this, you're going to have minus 18. All right, so we go to 5. So we blind the row and the column that contains 5. Then you are going to have for 5 you're going to have, if you blind the row and column, then you're going to have 3, 1, oh sorry, 2, it's 2, 2, 1, 3, 4. So it's going to give you 2, 1, 3, 4. It's going to give you 8 minus 8 minus 3, which is going to be 5. Then we move on to the next row. That's 2. So for 2, you have blind the row and column that contains 2. If you blind this place and you blind this place, then it means you are going to have 0, 5, 4, 0. So when you run the transpose, it's going to give you 0 minus 20, which is minus 20. I mean, sorry, if you run the determinants of the 2 by 2 matrix that you have left there. Now, the next one, you continue like that and continue until you get to the last one. Let's look at the last one here. This 0 here. So we blind this whole column and blind this entire row. So we are going to, so we say for 0, the last one now, it's going to be, okay, we have blinded this. So it's going to be 1, 0, 2, 1. So it's going to be 1 minus 0, which is going to be 1. Which is going to be 1. Let me put this one properly so that you don't mistake it as an equality sign. Oh, is it 1? Yeah. So what we do now is that where we obtain 24 from, the number we blinded to give us 24 will now be what is going to take the position of 24. So you create a matrix system. So I think I can save this page. So you create a matrix system again, which is going to be a 3 by 3. So when we did the when we isolated the column and the row for 1, we got minus 24. You can just scrub, you can just tap back and then you see how it is obtained. So so it means that in place of 1, we put minus 24. So we create this new, and we say this is minus 24, minus 18, and 5, minus 20, minus 15, and 4, minus 5, minus 4, and 1. So we close it up like that. And then we do the last magic on it. We perform the last magic. Now we multiply it by signs. So we often start with addition, subtraction, addition, subtraction, addition, subtraction, addition, subtraction, addition. All right. So if we do this multiplication, whatever it gives us here, we are going to call it the cofactor, cof of sorry. So we'll call it the cof of okay, of M transpose. All right. So that's the adjugate of M transpose. So 24 times plus 1. 24 times plus 1, that's going to be, I mean, minus 24 times plus 1 would be minus 24. All right, minus 18 times minus 1, plus times minus, that's going to be 18. Okay, 5 times, oh, that's going to be 5. There's no problem with that. Then you go to the next one. This is minus times 20 times minus 20, that's 20. Then this is plus times plus times minus 5 times minus 15, that's minus 15. Then 4 times minus 4, that's minus 4. All right, so we'll move to the last one. Minus 5 times plus, that's minus 5. Then minus 4 times minus, that's 4. That's 4. And 1 times, that's 1. So we can now say that the uh, adjugate of m plus, or cofactor of m plus, is now um, minus 24, 18, 5, 20 minus 15 minus 4 minus 5, 4, and 1. So to get the inverse, so m inverse now is going to be the inverse of the adjacent, of the determinant of m times the, what's it called now? The adjugate of m transpose. So we have found m transpose. This is m transpose. This system here is m transpose, and this is the adjugate of m transpose. So we have found this guy. Don't forget we have found the determinant earlier to be 1. So you just multiply 1. 1 is in the video I sent to you earlier. 1 is a scalar. It's just a number, so you can use it to multiply. Okay. So when we do this now, we can now say that m inverse is actually going to be, since if you multiply anything by 1, it retains the value. It means that when we multiply 1 with everything we have in this aggregate matrix, it's still going to be the same thing. So it's going to be minus 24, 18, and 5, 20 minus 5, sorry, minus 15, and minus 4, minus 5, 4, and 1. And that is the inverse matrix. Now, the good thing about this is that you don't need to go through this stress. There are calculators. Let me see. Let me see if I can demonstrate it on my phone. There are calculators that could easily do this for you. Let me save this page first, so that when I come back, I don't have to see it. Okay, let me just leave it there. So there are calculators that can do it for you. I think I have. I thought I had that calculator earlier. Yes, this one. I like this one. This is actually specifically a matrix calculator. It's going to, okay, I thought it was going to advertise. Thank God it didn't advertise anything. So what you are supposed to find, okay, you can see the transpose here. You can see the rank. You can see the determinant. You can see everything. Now you can see the inverse. So find the inverse. So if I punch these values, the values I had earlier, if I punch the values I have earlier into it, so all I have to do is to put this as a 1. So I'm looking for the inverse of 1 and blah, blah, blah. So I just put 1, I come here and put 2 here and put 3. Then just below I put 0. Next I put 1. Next I put 4. Next I put 5. Then I put 6. And I put 0. Let me be sure. 1, 2, 3, 0, 1, 4, 5, 6, 0. Fantastic. I can just find the inverse straight. All I have to press is find inverse. Let's see. It should have calculated it somewhere. Yes, it has calculated it. It has calculated it here. I think you can see the inverse here. If you compare it with what we have is minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, and 1. That's all. Okay, so let me go back to, excuse me. If I go back to the screen where I was working on, so you can see the same thing. The same thing. What what took us like 1 million hours to solve using the manual method, the calculator just brought it out perfectly in a few seconds, just or less than a second to solve. Yeah, but that's the calculator. What is important is you knowing what you are going to punch into the calculator, and this is the reason why we are doing this. Now, for instance, let me continue with one last trick. I'm not going to solve it, and most likely it's not even going to come out of your test. But then, if your professor is crazy enough to bring it out of your test, then you know that this is what you're going to do. That it's not likely for you to find a calculator that would do the division of matrices for you. Okay, so you're asked to divide two matrices. What are you going to do? So let me save this page. Let me save this page and demonstrate how that will work. So let's assume that I have. Okay, another thing is this. Let me mention something. It's only square matrices that you can find their inverse. I mean, when you like, what's a square matrix? A square matrix is a matrix that has the same number of rows. Excuse me. A square matrix will have the same number of rows and the same number of columns. So let's say A, B, C, D, E, F, G, H, I. So this is a square matrix. So it's only this kind of matrices that you can find the inverse of, right? You can't find the inverse of anything that is not square. This is like a 3 by 3. So if you can find the square matrix of a 2. I mean, you can find the inverse of a 3 by 3, 2 by 2, 4 by 4, blah blah blah, hen by hen, hen by hen. But then you can't find something like a 2 by 3. No, you cannot, because you can't find the determinant of a matrix that is not square. And if you can't find the determinant of a matrix, and since determinant happens to be one of the ingredients that you will need to solve for the inverse, then it means that only a square matrix can be inverted. And again, like I said earlier, if the determinant of the matrix is equal to 0, don't even bother to look at it. Now let's look at what we have learned so far. Let's practicalize it. Of course, in finding the division. So you are given A. You are given A. You are given A as a matrix. Excuse me. I think. Okay. You are given A as a matrix, which is a 3. Let's say is a 3 by 3 matrix. 3, 2, 1, 1, 4, 0, 1, 2, 3. Then you are giving B as another matrix. Okay, in this time around, let's say it's 1, 3, 2, 4, 1, 5, 3, 3, 3. Okay, so we have this matrix, and they say what is find A over B. All right, may we not be given this kind of problem in our, but then it's not difficult. It's not difficult at all to find it. What you do is this. You know that A is a 3 by 3 matrix. All right. B is also a 3 by 3 matrix. Now, definitely B inverse will be a 3 by 3 matrix. So, all you will do is to say find B inverse, then multiply it by, and multiply A by it. So A comes first, not B first. So it's going to be it's going to be A times B inverse. All right? A times B inverse. All right? So because this is the same thing as A times 1 over B, which is the same thing as A times B inverse. So all you need to work on is on your B inverse. You work very hard on your B inverse. First of all, to find B inverse, first find the determinant of B. Second, find the what's that thing again? I forget things. Transpose of B. So find the B transpose. Thirdly, find the adjugate of B transpose. Adjugate of B transpose. Make sure that this determinant is not equal to 0. If it is equal to 0, it means that you cannot divide, you cannot find A over B. That's what it means, because you don't divide numbers with 0. All right, so that's it. So when you have found this, then find the B inverse, which is going to be the determinant of B, which we have found earlier, times the adjugate of B transpose. When you have done that, then you can now come and do a multiplication of A, that is A now times everything you have found here, B inverse. So using multiplication of matrices. And will it work? Why not? A is a 3 by 3. B is also 3 by 3. So it means that A has a column 3 and B has a column, A has column 3, B has row 3. So since they are equal, then they can work. Now, this is 3 here and this is 3 here. It means that your result is going to be, so A times A divided by B is going to give you another 3 by 3 matrix. So please let me know your thoughts about this. Let me stop for now. Thank you very much.